Hi, good morning and good evening, everyone. My name is Pao, and I work as a data scientist. I'm also an AI data science advisor for the project Pascal. I'm delighted to be the host for today's session, where we will be discussing the topics of data science in everyday's life, practical application, and insight. I'd like to extend a warm welcome to all of you and express my gratitude for making this AI discussion forum possible. Today, we are honored to have a distinguished guest with us, Prof. Joyce Shen, who graciously accepted our invitation despite her busy schedule. Joyce is one of the esteemed lecturer in MIT's program, Master in Information and Data Science at UC Berkeley's iSchool. Her expertise lies in emerging technologies for enterprises, big data, analytics, machine learning, AI, as well as cybersecurity. Notably, she has authored books on technology innovations and holds a patent for detecting, locating unsecure sensors in critical infrastructures. Joyce earned a dual bachelor degree in statistics economics from the University of Chicago. She also holds an MBA with concentration in quantitative finance, entrepreneurship, and strategy from the University of Chicago Booth School of Business. Now, I would like to hand over to the floor to Kang Tae-yong, who will introduce our panel students for today's discussion.
Thank you, Professor Shen, for making your time to do this. I'm Taeyong, the founder of Project Pascal. We would like to extend our warmest gratitude to Mr. Chang for graciously inviting our esteemed guest, Professor Shen, to join the Pascal movement. Professor Shen's profound knowledge and expertise in cutting-edge technology is truly a remarkable source of inspiration and guidance for the students participating in our movement. We deeply appreciate Professor Shen's invaluable contribution as she generously shares her insights and expertise in the continuously evolving scene of technology. So once again, welcome Professor Joyce Shen to the Pascal movement. Before we begin, I think we can have a quick introduction of everyone on our panel today.
Hi, Mission. I am James He, co-founder of Project Pascal and a physics student deeply passionate about physics and its potential to address the challenges we face, which includes the pressing issue of climate change. I'm particularly intrigued by the convergence of physics and machine learning, as it holds the key to developing innovative solutions.
Hi, Mission. I'm Chen Su, the head of research in Project Pascal, a passionate math student with a background in Math Olympiad, and also a desire to become a data scientist through a major in math. And I also have substantial interest in machine learning, given a myriad of machine learning projects I've done. Hence, I aim to explore the role of AI in math and physics through conducting machine learning research projects and contribute to this rapidly evolving field.
Hi, Prof. Shen. I'm Sang-in. I'm the head of communications at Project Pascal. And my interest lies in not only the field of science, but also its profound impact on society. And as someone whose formative years were characterized by breakthroughs like smartphones, electric cars, and chatbots, I believe that technology has the potential to further transform industries and address societal issues when it's used correctly. And so I'm eager to explore the potential implications, both positive and negative, that arise from the integration of technology into our society, and how we can harness technology to shape a more equitable and sustainable future.
Once again, hi, I'm Taeyong, and I'm the founder of Project Pascal. As an active, math and physics Olympiad student, my passion lies in spreading awareness of the significance of mathematics and physics, and inspiring others to embrace them as essential life skills, rather than daunting and monotonous subjects, especially in this ever-evolving world. So I personally aim to do so by introducing creative ways of approaching problem solving in these subjects and helping people understand that it's more akin to solving a puzzle rather than it merely being regurgitation of information. So now I think I move on. So in an age defined by technological advancement, mathematics and physics stands as a universal language that drives innovation and unlocks the solutions to complex problems. However, with accelerations in technological advancement, the gap between those who benefit and those who are left behind widens. So that's where Pascal movement steps in, igniting a passion for mathematics and the sciences, empowering students to shape their futures. Project Pascal is a passionate and transformative movement led by a group of visionary students from Raffles Institution. Our mission is simple yet powerful: to provide a platform that transcends barriers of nationality, socioeconomic background, and race, giving students from all walks of life an equal opportunity to explore the captivating world of mathematics and physics. We firmly believe that mathematical and scientific literacy is a key to unlocking one's full potential and paving the way for success in an ever-evolving society. Through Project Pascal, we strive to nurture critical thinking skills, foster personal growth, and ignite a passion for learning. Recognizing the importance of adapting to a rapidly changing, technology-driven society, the initiative strives to equip students with the necessary tools to thrive in such an environment. So I think we can move on to the question and answers segment now. So on to you, Chenxi.
Hi, Ms. Shen. So I'll proceed on with the first question. So in today's rapidly changing era of artificial intelligence, technology is driving transformative changes across society, and mathematics and physics play a crucial role in the application of AI, and its influence permeates various aspects of our lives. The integration of mathematics and physics into technological advancements demonstrates the ongoing growth of these fields and the potential for further development that will further impact human life. Hence, my question to you, as an expert in AI and its applications, is could you please provide some insights into the most innovative and influential ways in which data science and AI are currently applied in everyday life? And it will also be very valuable to hear your perspectives on the future development of these technologies. So please share your thoughts and expertise on the subject.
Thank you for the question, Chenxi, and it's a pleasure and honor to be here and to share my experience and insights with you. I think the mission is really inspirational, as you talked about, that technology and innovation, now specifically around AI, can be a great equalizer to bring people together and to drive our society forward. And to specifically answer your question, machine learning AI are actually pervasive in our lives now for many years, some of which are embedded, which we don't think about that it's driven by machine learning AI, and others are more still in the early phases of development and adoption. So let me give you some examples. Our smartphones have a different recommendation system as to what app you could use, what time we should go to bed, tell us what time we should go to bed. When we go onto e-commerce website, we got recommendations of what to purchase. The navigation systems that we use on our smartphones, like maps or in our cars, these are all powered by big data, alternative data, and the application machine learning, specifically in those examples, recommendation systems. But there are also other applications where perhaps as consumers, we don't think about every day, but they're changing the way that industries are creating their products, finding solutions to meet their customers' needs. So for example, in healthcare, we're increasingly seeing that hospitals are adopting technologies that can assist doctors to diagnose different kinds of diseases, for example, cancer, by looking at the images. That's an application of image recognition and computer vision. Another example is in the future, think about the care economy. I recently read the report about the growth of the elder population in all developed countries and in many parts of the world. And in the future, we're going to have a shortage of human capital to care for the young people and for the old people. And there's a lot of innovation around how do you apply robotics, machine learning, and general artificial intelligence in many ways, so that we can bring more technology innovation to meet the gaps where we actually will not have enough human to solve those problems. So it's everywhere. There are also areas where in the factories, more and more machines are now with sensors, and with more of these sensors and digitization of machines, we're able to understand, we're able to collect data about how these machines are running, when they're running, how they're performing. And that's an area called predictive maintenance. So how do we apply machine learning to gain insights from this raw information coming out of the floors of factories to understand how can we better operate these infrastructure to produce better products more efficiently, more effectively, again, given the constraints and the dynamics of that our world is facing.
All right, thank you so much for that. I really found your answer quite illuminating about how AI is being applied in so many different fields and I guess different sectors of our world, like industry, for example, and in so many different places and I guess sectors. So now moving on to my second question about I think something more related to the environment, that one of the most urgent problems that we encounter is the need to transition into sustainable energy sources and mitigate climate change. So from your own understanding as a physics student, right, the current simulation models that of climate change and I guess the climate in general is dependent on a combination of physics modeling and artificial intelligence. So thermodynamics and fluid dynamics are utilized to create realistic models of atmospheric behavior, while AI is currently being used to analyze vast amounts of climate data and consequently identifying patterns that help in understanding climate change dynamics. And it's also crucial in improving sustainable energy systems, especially with regards to optimizing efficiency. So Professor Shen, as an esteemed data science expert, I would greatly appreciate your insights on the role of data science and AI in tackling the challenges we face for climate change. So could you please share some specific examples of real-world applications where these technologies have made a significant impact in combating climate change?
Thanks, James, for that question. It's another great question. I think it's a great continuation of the question that Chen-Shi asked. So you're absolutely right that the application machine learning in broadly speaking climate is hugely important areas of research and industries applying these techniques to problems. So in my view, if you think about climate, you talk about some of the areas, it's not just one thing, right? When we think about climate, there is the actual environment, there is which relates to how our food is produced. There is the weather and the ecological system. There is the way that we consume products, which sometimes the derivative of that is waste. And waste will have to be dealt with. Otherwise, it will create additional pollution. So there are many facets of thinking about climate and environment, and it's ripe for using machine learning in some ways to think about these problems differently or advance the solutions to these problems using machine learning AI. So a couple examples, I think starting with the obvious ones. So think about understanding the weather. We're taking for granted there is pretty accurate weather forecast every day, but in fact, that is actually a big machine learning problem. You have satellite imageries, you have sensor data, you have other sorts of data that's being collected. How do you develop the better forecast models, whether it's supervised machine learning or unsupervised machine learning or applying computer vision to these different types of data to understand not just the weather of tomorrow, but kind of the long-term weather prediction, because that insights would help with agriculture, supply chain, resource management, like food and other raw material management, because a lot of things depend on weather. So that's one area as an example. Another area is agriculture. So today, agriculture is being viewed as one thing, but in the world, we have significant food shortage and food security problem. Again, many individuals, sometimes including myself included, we take granted for the food that's on our table. The farmers have to deal with variations in weather, increasing challenges in crop diseases, so crops developing disease. So they have to consider how much pesticides to put on these crops, how much fertilizer, and all of those have implications to the larger atmospheric dynamic in the world. And so there are a lot of companies, innovators that are applying, machine learning to understand like optimization, to understand where and when and how and for what crops should we apply fertilizers and pesticides, because the more we do that, there is additional implications. Related area is water and soil health. Perhaps maybe not in Singapore, but there are areas in the US, in California on the West Coast, there is significant water shortage and droughts. And so we've had many projects looking at applying computer vision and other types of analysis to understand where will be the droughts, and perhaps how do you direct the way in which we farm and manage our resources to accommodate for these natural disasters and natural phenomena where we're just going to have less or fewer of these things. And then moving on to, on the other side is, for example, this idea that how do we make consumers consume more smartly? Because we're the ones who are consuming a lot of different resources, and we create lots of trash and waste, right? Think about all the packages that are delivered to us, plastic, paper, everything, and they don't get reused. So there are a number of companies that are really thinking about, again, how do you take all the different kinds of data and using supervised machine learning and perhaps even more advanced techniques to say, how do we optimize that process? Packaging, of routing our packages, and what type of packages, so what type of material can be used for future packaging so that we can reduce the overall consumption of these raw materials, which later on will also reduce waste. And waste management is another area. And then the final area that I want to touch on is what you often hear, that's not really climate and environmental specific projects, but it's adjacent to that, which is in the enterprises and corporations, the ESG, environmental, social, and governance. And in Europe, in the US, in Asia, there is increasing demand from consumers and also government and society to say, how are organizations manage themselves to consider environment, to consider social areas, and to consider governance, and how to be overall better organizations. And guess what? A lot of that has to be done with data. So the first step is, how do we actually find these data, alternative data, and first-party data inside these organizations? And again, using perhaps not necessarily really sophisticated advanced machine learning, but essentially machine learning techniques, and developing models to evaluate and assess the ESG posture of this organization. So with the hope that the insights from these models can steer or orient these companies to perhaps do more of the better or the good, and then do less of something that can improve on things where reduce carbon emission or manage their employees better, thinking about all kinds of different aspects where the derivative outputs of their actions actually will have impact on overall climate in the future.
Thank you. I think that was a really great answer. And those are some really insightful examples of how AI is already being inextricably linked into our daily lives. And I think, in fact, the last part of your answer on companies ties in nicely to my question, because my question links to the broader economy at large. So something a lot of people have noticed is that the largest companies in the world a few centuries ago traded in spices or textiles, but now they produce smartphones and chatbots. And I think this reflects a shift in focus of the society at large. We live in a world plagued by problems that seem insolvable, persisting inequality and declining populations, as you mentioned. And technology promises to offer innovative solutions, which is probably why so much of our lives revolves around the latest advancements in technology. As an investor, so my question is kind of two-pronged. Firstly, as an investor, would you agree that the economy now is shaped largely by technological developments? And secondly, at the same time, the current technocracy has been criticized for entrenching the wealth divide. What are some solutions that you believe can help mitigate the disparities caused by technological advancements?
Yeah, great questions. Well, to the first part of your question, I'm a little bit biased. I absolutely think so. I think the overall, the global economy and the local economies and where the growth opportunities will come from will be driven, whether explicitly or implicitly, by technological innovation. So if you look at the publicly traded, the public equity side, the growth companies are largely tech enabled or tech native. And even if you look at the companies that over time accrue significant value where they're not in the technology industry, they likely have a lot of technology embedded over time to help them to find better products, to understand how to better serve customers, and to understand how to better distribute so that they can actually create more value for their shareholders and for the market. So absolutely, I think the change that technologies bring to how we live, how we work, will not go away. And I think the pandemic was a great example of that. Imagine that if we did not have technology, if we did not have virtual conferencing, if we did not have our smartphones, and we had the pandemic, we would not be able to get sort of the kinds of services that we otherwise have gotten through that very difficult time. Being able to learn online, be able to work remotely, while there is a population, as we talked about earlier, that they have to go and work physically. Right? We have people who are delivering products, no matter it's a pandemic or not. They drive the trucks, they ride the bikes, the postal workers and so forth. But the technology has really lessened the impact, the economic impact for society as a whole, because it's providing a lot more options for people to find opportunities to work and to contribute to the economy. And so I think, yes, technology will be a growth driver, a huge growth driver moving forward. Personally, I even hypothesize that some of the more traditional economic models in understanding human capital and supply and demand will likely need to be updated because those traditional models have not taken into account the kind of innovation and access technology is able to bring to society in the current era. Can you repeat the second question again?
My second question was, what are some solutions that you believe can help mitigate the disparities caused by technological advancements? The disparities caused by technology advancement. How do we mitigate those? Yeah, I think that's a great question. One of the things I think you alluded to is that technology and understanding how to apply technology can help people create more value and over time more wealth. And for a set of population, if they have no access to technology or little access, they may not have the same access to education, to understand what services is available, what opportunities are available to them. And that is a huge problem. So I think this gap in terms of access in US and in many parts of the world, think about some of the remote areas, developing countries where they don't have internet or stable internet. Today, if we don't have internet, we don't have access to broadband, how are we supposed to get information and learn? And that's the starting point, is that people who have access to Wi-Fi, to phones, to computers are able to learn much more and perhaps learn much faster than those who don't have access to information. And information is power. So that's number one. So there are initiatives, for example, in the US and there in other parts of the world where I'm less familiar with, where a key question is, how do we bring broadband, not machine learning AI, how do we bring broadband and Wi-Fi to remote areas so that kids can have access to online education to augment their education in school, or if they can't go to school, they still have access to that. So that's one thing that I think we can do. The other is democratizing education in technology. Perhaps in Singapore, it's
it's a requirement. All of you are so smart, learning math and science and physics, and it's not the case for every part of the community and society. And there are a lot of people who perhaps are users of technology through their phone, but they intrinsically do not necessarily understand how technology innovation is moving society forward and where are areas of opportunities and value creation. And they need to be taught to do that. And so the other big thing is how do we get more people, more students, especially underserved communities, kids who are not able to go to the best school, who do not have access to computer science classes or even math classes, to encourage them to learn coding, engineer, data, but also this idea of data literacy and technology literacy, because we are seeing advancement in AI, and there are lots of misinformation, deep fakes, which relate to a lot of other problems. This audience, we understand how to protect ourselves and understand what is right and what is wrong, what's harmful, what's not harmful. For many people, because they don't have the background and they don't have the training, they are not in a position to understand what is harmful to them and what's not harmful to them, perhaps enabled by technology. And so education is another big area. Education about digital innovation, education for more advanced level of technology, machine learning, science, math, that will really help the people who are disadvantaged, because that will give them opportunity, that give them more knowledge to pursue things they otherwise would not necessarily have the opportunity to do so.
Thank you. And back to Theo.
Thank you, Professor Shen, for your insightful response. So I think we can take away like two main things from our response just now, which is that firstly, that growth in economies will be driven by technology, which was like quite clear during the pandemic, where we could see that technology has become an indispensable tool for companies and firms. And the second point being, there are ways for us to like bridge the gap in the terms of like access to technology. And the first way that she proposed was to finding ways to give perhaps underprivileged groups like access to technology. And the second one was the democratization of technology, which is done through education in schools, especially to improve students' data literacy and technological literacy. Okay, so I think I'll move on to my question now. So the mathematics of artificial intelligence, grounded in linear algebra, calculus, and statistics, serves as the fundamental pillars supporting AI methods. Understanding these mathematical concepts not only allows individuals to leverage AI, but also empowers them to become creators and producers, rather than mere users. So through Project Pascal, we aspire to create a global movement that explores fascinating realms of mathematics and physics, making them accessible to all students, irrespective of nationality, socioeconomic background, or race. We hope that every student can thrive and adapt to technological advancements without being left behind. As such, Professor Shen, I would greatly appreciate if you could share your insights and advice on what academic orientation and preparation will be most beneficial for students in the AI era. How can we best prepare ourselves to succeed in our future studies and society in this rapidly evolving field?
Yeah, I love that question. I think the two things. One is learn how to learn, because we can't learn everything about tomorrow because we don't know what's coming tomorrow. And as we talked about, technology advancement are just making things change very fast, both on the fundamental side of AI and machine learning. The new algorithms come out every day. Infrastructure gets better. You have new types of emerging companies that are creating new tools for developers and builders. So it's really moving really fast on the technology side. So what I encourage my students and others do is that even with all the changes, there are a few things that are constant. One is, as you talked about, the foundational knowledge about how things work in technology, engineering, science is underpinned by what we're taught in math, statistics, linear algebra, all the courses that we take in universities and graduate schools. Those theorems, those discoveries continue to underpin the new algorithms, the new things that come. And so that's number one, is really having strong foundation, because that's the base of the house. And no matter how the environment changes, that house is strong because it has a strong base. And the second thing is, if you think about one of the key things about being able to learn as an engineer, as a data scientist, as a scientist, students who go through this process, is that we learn critical thinking skills. We have both qualitative and quantitative understanding of how things work. And we're able to take a phenomenon, and then we're able to use mathematics or statistics or econometrics, modeling to represent this phenomenon in a quantitative way. And in many ways, machine learning AI, that is the core of that, how to represent the data we have, understand insights, and try and make decisions and create the right actions. And so this idea of applying critical thinking, applying our quantitative and qualitative critical thinking in all areas is very important, because we have quantitative and qualitative critical thinking skills. No matter how fast the changes are coming, no matter what new models are being created, no matter what new infrastructures are being launched, we have that mindset and that skill as problem solvers to really break down complex information components into simple elements and apply our critical thinking skill and say, okay, let me figure this out. That's number two. And number three is that even with all the different changes, and I posit that the changes will come even faster in the future, especially now with all the advancements in AI, is having a perspective of how do I use the knowledge, the skills on the technical side responsibly. Machine learning AI has huge potential to really help our society. At the same time, as I mentioned, there are also lots of bad actors, and this could be used in different ways that can create intended or unintended consequences to humans, to all of us. Part of education, as part of rising next generation scientists, mathematicians, data scientists, machine learning engineers, we should think about that. How do we use science and AI for good and create more value for society and for human at large? And asking questions about, if we build this product, what are the unintended consequences or intended consequences? How will people use this? And how can we risk manage and mitigate some of those consequences ahead of time so that we can really create the benefits and not necessarily creating more problems?
Thank you, Professor Shen, for your insightful response. So I think in today's discussion, we have actually covered a wide breadth of topics. Firstly, we discussed about the everyday applications of data science and AI in our society. And we also discussed the role of AI and data science in tackling the challenges of climate change, in which Professor Shen shared with us a variety of ways in which we can collect data and actually use them to help us in mitigating the damaging effects of climate change. And she also discussed with us on how we can actually bridge the gap when it comes to technology. And finally, she also shared with us on how we can succeed in this rapidly evolving field through firstly learning how to learn, developing critical thinking skills, and finally preempting the potential unintended consequences of our potential creations or actions in this AI world. So I'm sure that all of us can agree that your sharing today has really broadened our world perspective when it comes to AI and data science, that has really been a joy to be able to discuss this subject matter with you. Yeah. So back to you, Mr. Chang.
Thank you, Theon. Thank you, Prof. Shen. This is a very stimulating discussions and very insightful. Given that the time constraint is about time for us to conclude our discussion here today. I'd like to express my gratitude to each of you for sharing a valuable views and contribution, especially Joyce for taking the evening time to share all these views that we couldn't get it from anywhere else. This is really many years of experience and practices. I'd like to conclude our discussion for today and wish you all a wonderful weekend ahead. Thank you once again for the participation.
Thank you for your wonderful questions. And you are the future, and I wish you all the success.
Thank you so much.
Thank you.
Thank you.
Thank you.